Now, I didn't finish this one, but basically you've got 9 girls on a softball team. How many different lineups can be created? Well, 9 of them could bat first, and 8 of them could bat after that first one has already batted, because you can't bat twice in a row, no matter how good you are. So you go 9 all the way down to 1. That's going to be something in the 300,000s. Okay, specifically 362,880. But when you get to something like this, speed skaters competing in a race, medals are awarded for first, second, and third. Now, we're not just going to say, okay, well, that's just the same. It's 6 times 5 times 4 times 3 times 2 times 1. Not necessarily, because there's only 3 spaces. It would be 6 times 5 times 4, and then you stop there. So that would be 120. Okay? So if there's a $25,000 prize for any fan who can randomly select the final medal standings before the race starts, the probability of winning that prize, well, yeah, there's only one right answer out of 120, so just be aware that probability questions are usually going to have to do with one option out of a total number. And so sometimes you have to calculate that number. Sometimes you have to, just say it's one out of that many. Now, if Phil is certain to win first place in the race, how many different ways can the medals be awarded? So let's say Phil is a speed skater that just won the Olympics and he's competing against his high school buddies. Okay, he's probably going to win. Or if he somehow has jet-powered ice skates. Okay, regardless of how he's going to win, if he's guaranteed, this decision chart should not look the same as that decision chart. This should start out as a 1 because he's guaranteed to win. There's only one winner if we know Phil's going to win, whether he cheats or whether he's just that good. But after he wins, then how many people could get second? 5 and 4. So there's only 20 different combinations. Cuts down on it quite a bit if you take the leader out of the race. Same kind of thing, you look down here at 13. A train is made up of a locomotive, 4 different cars, and a caboose. Now the locomotive must be first and the caboose must be last. How many different ways can the train be ordered? 1, 2, 3, 4, 5, 6. There's 6 trains, even though we know what some of them are. So as we sort of start placing them, it's important that you kind of do what you know first and then fill in the general information later. There's a 1 at the front, and the caboose can only go there. So as you're positioning them, there's 4 cars that can really go anywhere. So 4, 3, 2, and 1. Yeah, the 1 and the 1 show up a bunch. Those just mean there's not going to be any difference once you get down to that. So 4 times 3 times 2 times a bunch of 1s, there's 24 different ways that could be done.